Hello and welcome back to Dr. Logic awkwardly does logic in a kitchen, which really is just too cold, even with the radiator behind me. This video, very brief, very quick, going to give you the first formal definition that we need for substitution. And because formulas are built up out of terms and predicates, first we need to talk about the substitution of terms. So, our handy dandy whiteboard. Here is our definition. So this is the definition of the substitution of terms. What we want to do is take an arbitrary term and then tell you what the result of substituting some other term into that term is according to what type of term you're substituting into. Anyway, it's easier when I write it out. So let tau and tau1 be terms and x a variable. What we are going to define is tau1 slash x. So this is the substitution of, just a moment, there we go, tau1 in for tau in, sorry. This is the substitution of tau1 in for x in term tau. So let me get rid of the wrongly written bits so that, there you go. We are substituting tau1 in for the variable in the term tau. Now, this is defined recursively depending on what tau is. So if, first case, if tau is a constant, then nothing changes because we are substituting in for variables. Constants are not variables and do not contain variables. So if tau is a constant, then the result of substituting tau1 in for x in tau just gives you back the constant that you started with. If tau is a variable, well then, the result of substituting tau1 in for x is just going to be tau itself if it is a variable that is not x. So if it is the variable y and you're substituting in for x, then you're just going to get y back. But it's going to be, so it's going to be tau1 if tau does equal x. So if I have, say, the variable x, and I want to substitute in some term a in for x, the result of this is just going to be the term I substitute in. It's going to be a. Then, if tau is actually the result of applying a function to some other set of terms, say sigma 1 to sigma n, then the result of replacing tau1 for x in this is just going to be the result of doing the substitution on each of the individual terms. So it will be the f of, I'll take sigma 1 and substitute tau1 in for x. And you do this all the way up to our last term, sigma n. So there you have it. Constants don't change. Variables become the thing that you substitute in for if it is the variable, if the variable is the one that you're substituting in for. If it's not, then it just stays the same. And complex terms formed out of functions just reduce to applying the function to the substituted version of each of the terms inside. And so you can see how this is recursive because this sigma here is going to either be a constant, a variable, or the application of a function to some set of terms. And eventually you just keep unwinding it until you're down to the base case of constants and variables. And these are well defined. So there you have it. Substitution of terms where you replace some term in for some occurrence of a variable, or some free occurrence of a variable. Next, we will talk about how this plays into substitution for substitution of terms in for variables in formulas and sentences, but that's another kind of slightly more complex definition and deserves a video of its own. So join me for that. See you then. Cheers.